everybody. So we are on our statistics unit, and today we are going to be looking at something called standard deviation. But before we get to that, let's look at the do now. The do now says the solution of the equation, and then it gives this, is. Now, whenever you have x squared, this tells you have a quadratic, and to use the quadratic formula. Okay, so we're first going to start by writing the quadratic formula. It's been a while since we've done this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what we have to do here is we have to identify a, b, and c. Okay, so looking at what we have here, it looks like a equals 2, b equals 3, and c equals 2. So let's plug that in. So we have x equals negative, always use parentheses when plugging in, b, which is 3, plus or minus the square root of b, which is 3, squared minus 4a, which is 2, and c, which is 2, all over 2a. Okay, so now we get three numbers from here. We get this number in the front, we get the number underneath the radical, and we get the number in the denominator. So negative 3 stays negative 3. 2 times 2 is 4. And now let's use our calculator to get what number goes underneath that radical symbol. So we have parentheses 3 squared minus 4 parentheses 2 parentheses 2. Notice I didn't type the radical in. You're not supposed to. And we get negative 7. So negative 7 goes under here. Now, we have a negative under the radical. Whenever you have a negative under the radical, that tells you have an imaginary number. So we do need to simplify this radical negative 7. So to simplify an imaginary number, the first step is to take out an I. When you take out an I, you're left with a positive number underneath the radical. Now, if we look at radical 7, we would simplify it by finding a perfect square that goes into it, but there's no perfect square that goes into radical 7. So this is going to change and become negative 3 plus or minus I radical 7 over 4. Okay, now let's look at our answer choices. I don't see this there exactly, okay, but I do see some answer choices I can cross out. I know my answer has to have an I, so it can't be 3 and it can't be 4. There's no I in either of these answer choices. I also know my answer needs a radical 7. Answer choice 2 does not have a radical 7, so that tells us our answer is 1. Now the way you get from this to this is you just divide 4 by both terms. So it's negative 3 over 4 plus or minus I radical 7 over 4, and then you just rearrange it a bit. Okay, so moving on. Before we get into standard deviation, let's review the measures of central tendencies. Now, the measures of central tendencies, that's your mean, median, and mode, okay? So the mean is the sum of all data points divided by the number of data points. Another word for that is average. The median is the number in the middle of a data set that's written in numerical order, so from least to greatest. And the mode is the number that appears most often. Okay, so that's just kind of a review of what those three words are. Now let's get into some standard deviation. So what does it mean to actually deviate from something? Now the word deviate means to go away from in simplest terms. That's exactly what the standard deviation is. It's the distance from the mean, okay? Not the median, not the mode, the mean. So the standard deviation is deviating from the mean. Now, what we're going to be using today is this line, okay? All you have to do is draw a line on your paper. In the middle of the line, that's always where our mean goes, okay? The mean is always going to be in the middle of the line. Now, you can go in a positive direction away from the mean and in a negative direction away from the mean. If you go one space over, however much that may be, depends on the problem, that is one standard deviation away. So this is in the positive direction, so plus one standard deviation. Now, if you were to go one to the left, that will be a negative one standard deviation away. If you were to go one more standard deviation away, now you have plus 2 standard deviations away from the mean. And if you were to go one more in the negative direction, you would be at negative 2 standard deviations away. I know this doesn't mean much right now, but we are going to be putting some numbers to what this means. So let's move forward. So here's an example. We have a mean of 10 and a standard deviation of 5. So our mean goes in the middle and it is 10. So this is our mean. Now, if we were to go one standard deviation, so plus one standard deviation, what that means is we need to add the standard deviation of 5 to the mean. So to get from here to here, we would have to add 5. That's one standard deviation away. So 10 plus 5 is 15. Now, if we wanted to go in the other direction, which was the negative 1 standard deviation away, instead of adding 5, we would subtract 5. 10 minus 5 gives us 5. So that's the minus 1 standard deviation away. And then we just continue that. If we want to go one more standard deviation away, which is plus 2 standard deviations, we would have to add 5 one more time. So to get from here to here, we would have to add 5. 15 plus 5 is 20. To go in the negative direction, if we were going negative 2 standard deviations away, we would just subtract another 5. So 5 minus 5 gives us 0. And this is how we are going to be writing our standard deviations today. Start with the mean in the middle, and then we add it to get to the positive side and subtract it to get to the negative side. So how do we get this information from the calculator? There are calculator steps to get the standard deviation and the mean from your calculator, and this is what they are. If you need to pause the video or take a picture, go ahead. So when you do type it into the calculator, which we are going to do in a second, this is what you get. So this would be your first screen, and then you're going to have an arrow pointing down. That means there's more information. If you scroll down, this is what you get. So it starts at this X bar, and it ends at max. Okay, all your information. Now, this X bar, that is your mean. Okay, the X with the line on top. Your standard deviation is actually represented by both of these points, okay? Now, the first one with the S, we are going to talk about. That is called your sample standard deviation. And the one with the circle and the line on top, so this is how you make it, circle with a line. It's actually a Greek letter. My people are represented. That is your population standard deviation. Again, we're going to talk about that right after this. This is your minimum value. Now this Q1, that's something called a quartile. Your MED, that's your median. Q3 is another quartile, and max is your maximum value. Okay, so now let's talk about the differences between standard deviations. So the population standard deviation, that's if you have data from everyone, so you're using every single data point. So that is when you use this Greek letter. It's called a sigma. It's a lowercase. So that's when you're taking data from everyone in your sample or everyone in your population. If you have only some of the data, so you're only using a portion of it, that's when you use the sample standard deviation. So if you look at the pictures, you see that this sigma is the whole population, but this S is only part of the population. Now we are going to be using the population standard deviation today, so we're going to be using the sigma. Okay, so again, these are the three main parts that we're going to use, or that we're going to use today. Mean and standard deviations, but again, we're not really going to be using this one too much. So we're really focusing on the sigma of x and that x bar, which is the standard deviation and the mean. Okay, so now let's practice actually using the calculator and using the mean and standard deviation process from earlier. So it says 10 students in Ms. Koskinas' class took a quiz with the following results in ascending order. Use the calculator to find the mean and the standard deviation. So here are going to be the calculator steps. You press stat. You press enter on edit. Now you're going to type your values into L1. So you type the first one, press enter, and then continue. So 84, 84, 85, 88, 88, 90, 93, 95, and 99. Okay, once you type them all in, you go back to stat, you go over to calc, and you press enter on 1, which is 1 bar stats. So then you go down to calculate. You can either press enter or scroll down. Just make sure you press enter on calculate. Now you need to know which are your points that you are using. Okay, so first things first, our mean is this x bar. So our mean in this case is 88.9. Our standard deviation, so again, for the sake of this class, we're only using the population standard deviation, is the sigma. So we're going to round it to the nearest hundredth. So it is 5.07 when it is rounded. So 5. Too sloppy for me. 5.07. Okay, so we've identified the mean and we've identified the standard deviation. Now part C says what is the range within one standard deviation from the mean. So to find the range, that's when you use that line method from earlier. So in the middle of the line goes your mean. So our mean was 88.9. Okay? So to get one standard deviation away, you add your sorry, I cannot speak right now. To get one standard deviation away, you add your standard deviation. So from here to here, we are adding 5.07. So let's go to our calculator and we do 88.9 plus 5.07. And we get 93.97. So this is 93.97. 0.97. Now to get to the other way, which is -1 standard deviations, because when it says within 1 standard deviation, it means both sides. We have to then subtract 5.07. So here we have to subtract, oh, my bad, 88.9 minus 5.07, and we get 83.83. Now, our range is from this number to this number. We can write it a couple ways. So you can write it like this. So 83.83 to 93.97. But more popularly, it's written like this. 83.83, comma, 93.97. Okay, but either one of those answers are correct. So now let's get within 2 standard deviations. It's the same type of process. If you want to use the same line, you can. I'm going to just rewrite it with our data points in there. So we have 88.9. We found that 1 standard deviation away was 93.97 and 83.83. So now we just have to repeat it again. So to get 2 standard deviations away, to get from here to here, we have to add 5.07. So back to our calculator, 93.97 plus 5.07, and we get 99.04. And we do the same thing in the other direction to get 2 standard deviations away. So to get from here to here, subtract 5.07. So 88.83 minus 5.07. Enter, and we get 83.76. So our range of values within 2 standard deviations is 83.76 to 99.04. 3 decimal right there. Okay. All right. So let's continue on. Extend the page here. Now, part E says what percent of the scores are within 1 standard deviation of the mean. So to do this, we're bringing in percentages here. So what we have to do is we have to take the number of scores within 1 standard deviation and then divide it by the total number of scores. That will give us a decimal. Then once we do that, we have to multiply by 100 to make it into a percent. But we're going to get there. But first, let's figure out what this fraction is going to be. Number of scores within 1 standard deviation. So this was the range of scores between 1 standard deviation. So we have to see how many of these data points are within this range. So let's look. So 83 is not in that range because this starts at 83.83. So that doesn't work. 84 is good, 84, 85, 88, 88, 90. 93 is good because it's less than this number. But 95 and 99 are out. So that leaves 1, 2, 3, 4, 5, 6, 7 out of the total scores of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 out of 10. If we were to do 7 divided by 10, we get 0.7. Now it asks for a percent, so we need to change this into a percent. You can either move the decimal point or multiply by 100. When you do that, you get 70%. So 70% of our scores lie within one standard deviation. So now let's see how many lie within two standard deviations. So make this a different color. Our two standard deviation range was 83.76 to 99.04. So to get there, what we have to do is we have to look at these. So 83 is in that range. So it's 84, 85, 88, 90, 93 is in that range too, 95, and so is 99. So 10 out of our 10 scores are within two standard deviations. 10 divided by 10 is 1. If you change that into a percent, it is 100%. So you see, the more standard deviations away from the mean we go, the more percentage of our scores or our data points are within that range. Okay, so let's move on to another example. Now what I'm going to do for this one is I'm actually going to show you how to get the standard deviation and the mean. Well, not how to get it. How to get these values here, the range, a different way. You can use whichever way you prefer, but I'm going to show you multiple ways to do it. Okay. So here it says the height of 15 players on Arlington boys varsity basketball team are given below in inches. So find the mean and standard deviation. Round to the nearest 10th. So we go to Stat, Edit. To clear this list, you have to go up to L1, press Clear, and press the down arrow. So let's type in our values. 66, 67, 68, 68, 70, 72, 72, 73, 74, 75, 75, 75, 76, 77, and 79. So then we're going to go back to Stat, go to Calc, go to One Bar Stats, and press Enter. If you get something different than I have here, you might have typed in the data points in L1 incorrectly, so just go back and check. So identifying the mean and standard deviation. So our mean is the X bar, okay? And that was 72 point. It says round to the nearest 10th, so 72.5. Our standard deviation which is represented by this Greek letter here, is 3.7923, but we're rounding to the nearest 10th, so it's going to be 3.8. Okay, so part A is done. Let's look at part B. It says determine the proportion of the populations that lies within one standard deviation and within two standard deviations. So I'm going to show you how to do this a different way. If you like using that line, how we did before, like this, go for it. But what you can also do is this. So you can have the mean, so X bar, plus or minus 1 times the standard deviation. Okay? So in this case, I'll show you what this means. Our mean is 72.5. So you're going to add and subtract 1 times the standard deviation, which is 3.8. Okay? So we have 72.5, we're going to simplify it a little bit, plus or minus 1 times 3.8 is just 3.8. Now you might sometimes even see the answer like this, so that's why I wanted to show this to you. Now, let's actually get the range here. Oh no. I want to move this over. Oh, that's not what I wanted to do. Yes, there we go. Okay, so now what this means is you have to do 72.5 minus 3.8. I am running out of space here. So 72.5 minus 3.8, comma, still not enough space, 72.5 plus 3.8. It'll look better with the bottom one, I promise. So now that's how you find the range. So first let's subtract the values. So we have 72.5 minus 3.8. So that's the first point in our range, 68.7. And the second point in our range, we have to add them. So 72.5 plus 3.8. And we get 76.3. So this right here is the range within one standard deviation. Sorry, it's a little messy. I swear it's going to be neater on the bottom. So let's do the bottom one, the one within 2 standard deviations. Now, within 2 standard deviations, so we have the mean plus or minus. Instead of this being 1, it's going to be 2 because we now want 2 standard deviations. And then times the standard deviation. So let's plug in our numbers. So the mean was 72.5 plus or minus 2 times 3.8. Okay, so let's figure out 2 times 3.8. So I like simplifying everything before I split it up. So we have 72.5 plus or minus 7.6. So now, again, this could technically be your answer, but we are going to get the full range. So this will get split up into 72.5 minus 7.6 and 72.5 plus 7.6. Notice the plus is always coming second. That's because you're writing the range from smallest to largest. So when you subtract, your number is going to be smaller. When you add, your number is going to be bigger. So let's figure this out. So 72.5 plus, oh nope, minus 7.6, and you get 64.9 as the first value of your range. And for your second one, you add. So if you press second, enter, it brings you back to what you typed in before. I'm going to scroll back and put the plus, and then we get 80.1 when you add them. So this right here is the range within 2 standard deviations. And this was it within 1. Again, if you like the method with the line better, that is totally fine. Just know that sometimes this one does pop up. Okay, so let's do one more. It says the standard deviation of a population characteristic measures. So the standard deviation measures the difference between the maximum and minimum values. Absolutely not. The difference between the third quartile and the first quartile. Absolutely not. The average distance the data is away from the mean. Okay. The average distance the data value is away from the median. Absolutely not. We don't use the median here. Number 3 is the distance away from the mean, okay? All right, so your check for understanding is here. I am going to show you how to get this calculator on Delta Math, so just stick with me after you after I explain this check for understanding. So, to get credit for this class, you need to complete this problem on a separate piece of paper and then upload it to Google Classroom. Now, for Delta Math, if you don't have a calculator, you can use Delta Math. To do so, you go over here where it's your calculator button. If you press this normal one, this is what comes up. That's not what we want. We want the statistics calculator. So press your statistics calculator. This will all pop up. You type your values into L1. Then you're going to go to Calc menu, Submenu, 1-bar stat. Okay? This should say L1, this should say nothing, and then you would press calculate and you would get all of your values. Okay, so that's it. Have a great day, guys.